Okay, so we're given a couple of different production functions, and we want to see if they have constant returns to scale, or decreasing or increasing returns to scale, and what happens to their marginal products of labour and capital as labour and capital increase. Okay, so the first thing we're going to do is figure out if this has increasing or decreasing returns to scale. Well, the easiest way to do that is what's the function of, or what's output when we have 2 capital and 2 labour? Well, that's 3 times 2 plus 2 times 2, which is equal to 6 plus 2, where 6 plus 4 is equal to 10. So what happens if we double our inputs? So if we go for what's the output when we have 4 of each, so it's double each, well, that gives us 3 times 4 plus 2 times 4, which gives us 20. Okay, so we doubled our inputs and our output doubled, so we have constant returns to scale. And the next thing then is we want to look at the marginal product. So what's the marginal product of labour? Well, it's just derivative of quantity with respect to labour, which in this case is just going to be equal to 3. And what about the marginal product of capital? That's just derivative of quantity with respect to capital, which in this case is just 2. So both of these are constant. They don't change. They don't change as you increase the quantities of capital and labour. So that's the first one. What about the second one? The second one is Q is equal to 2L plus 2K to the half, all to the half. So let's look at if it's got increasing or decreasing returns to scale. So if we have 2 of each unit, well then Q is equal to, or 2 of each input, Q is equal to 2 times 2 plus 2 times 2, all to the power of a half, which is equal to 4 plus 4, which is 8, so it's equal to root 8. What about if we 4, then Q is equal to 2 times 4 plus 2 times 4, the square root of, which is equal to the square root of 8 plus 8, so the square root of 16, which is 4. Okay, so I should say this is actually 2.8. Makes it easier to see. So we doubled our inputs. We went from 2.2 to 4.4, but our output didn't double, right? It went from 2.8 to 4. For it to double, for it to be constant return to scale, we would have had to go to 5.6. For increasing, we would have had to go higher. So we've got decreasing returns to scale. Okay, doubling our inputs, going from 2.2 to 4.4, did not double our outputs. In fact, it was less than double. What about the marginal products? Well, these are a bit more complicated than the last one, so if we just look at the marginal product of labour first. If you use the chain rule of differentiation, that gives you 2 over twice 2L plus 2K to the half. So what's this going to do? Well, as L gets bigger, this whole overall is going to get smaller, right? So you have an L in the bottom here. So you have an L in the bottom, so as L gets bigger, the overall thing is going to get smaller, right? So the MPL decreases with L. And if you do the same thing for K, if you do the same thing for K, look at the marginal product of capital, you'll see that that will decrease with capital as well. So the more and more capital and labour you add on to this technology, the smaller the kick you get with each extra unit. So the next one is Q is equal to 3LK squared. So what do we get in terms of Q if we have 2 and 2? Well, if we have 2 and 2, Q is equal to 3 times 2 times 2 squared, which is equal to 6 times 4, which is 24. What if we go for 4, 4? So we double our inputs. At 4, 4, Q is equal to 3 times 4 squared. So 12 times 16, which is equal to 192. Okay? Which is way more than double what we had at 2, 2. So here you have increasing returns to scale. If you double both of your inputs, so you double your labour, or your capital and your labour, your output more than doubles. So you have increasing returns to scale. What about the marginal products? Well, the MPK, or the MPL, sorry, we'll do first. You just differentiate this with respect to L, and you get 3K squared. Okay? So that's constant with respect to labour. So as you increase your labour, your MPL stays the same, right? Because when you look at these marginal products, you're holding the unit factor fixed. What about MPK? In this case, it's going to be 6 times L times K, right? So just differentiating that. And that's increasing in K. Okay, so as K gets bigger, it's increasing with respect to K. So as K gets bigger, you get more and more addition. As you increase your capital, the addition of each unit of capital to product is increasing. So the next one is Q is equal to L to the half and K to the half. So if we have 2 and 2, our Q is equal to the square root of 2 times the square root of 2. Remembering that halves mean, or powers of half means take the square root. So that's 4, or sorry, that's 2. And what about at 4, 4? Well, at 4, 4, Q is equal to the square root of 4 times the square root of 4, which is equal to 4. So doubling our inputs has doubled our outputs, so we have constant returns to scale. So then looking at the marginal products, so we'll just look at the marginal product of capital first, or we'll just look at the marginal product of capital this time. The marginal product of capital, so if you just differentiate this with respect to K, take down the half, so you get a half, L to the half, K to the minus a half, which we can rewrite quite simply as a half, do L to the half over 2, so putting the 2 at the bottom there, K to the half, okay, because we take the negative powers down to the bottom. So what does that tell us? Well, as K gets bigger, the bottom gets bigger. So as the bottom gets bigger, the overall fraction gets smaller. And you can do the same for L. So we've one last one. Last one is Q is equal to 4L to the half plus 4K. So what do we get at 2, 2? Keep with our usual numbers. So we get Q is equal to 4 times root 2 plus 4 times 2, which is equal to 13.66. And at 4, 4, Q is equal to 4 times root 4 plus 4 times 4, which gives us 24. Okay, which is not twice 13.66. So here we have decreasing returns to scale. Our output went up all right when we doubled our inputs, but it didn't double. And then if you look at the marginal product again, you can see quite quickly that the marginal product of capital is constant. Okay, so you just differentiate this with respect to K, you get 4, and the MPL is equal to 2L to the minus a half. Okay, so it's decreasing in L, so you can rewrite that as 2 over root L. So as L gets bigger, this whole thing is going to get smaller.